Since the dawn of the human species, we have sought to understand the world around us. There are two ways we do this, and every human that has ever existed has experienced some degree of both. The first is the moment of our birth and the commencement of learning. We explore our world, first with the most basic things, such as discovering how to consume nutrients, then crawl and explore, then walk and speak. Life really is a long series of learning lessons, the point of which is ultimately to arrive to as complete of an understanding of the universe as a human living on a planet can do. But we also learn cumulatively. We teach our children the early lessons of life we in turn inherited from our parents. But we're also helped by the cumulative knowledge of thousands of years of human existence. Sometimes this knowledge is lost, the Dark Ages being an example, where much of the literature of the Greco-Roman world vanished. But overall, the grand act of data collection by the human species has largely been a success, even to the point that we can reconstruct past knowledge to a degree with our modern technology. Case in point, the Epicurean philosopher Philodemus of Godier, who lived during the 1st century BC. Until relatively recently, not a lot was known of this philosopher other than mainly a group of poems that had been preserved by luck. Philodemus himself, however, had made a very fateful move in life that would come to define him over 2,000 years later. After studying in Athens, he moved to Rome during its period as a republic, before the days of the full-on empire. At some point, however, he decided the big city wasn't for him, and moved to the more or less resort town of Herculaneum, not far from Pompeii in the shadows of Mount Vesuvius. Philodemus died long before Vesuvius's violent volcanic eruption in 79 AD, but his library may have survived. Starting around 1752, excavations in Herculaneum started revealing carbonized papyrus scrolls. The discovery and excavation of these scrolls continues to this day, with almost 2,000 scrolls so far recovered. As exciting as that might sound, there's a problem. The volcano that preserved them also made them mostly unreadable. These scrolls were reduced by the volcano's superheated pyroclastic flows to lumps of carbon, essentially. But some managed to be at least partly readable, and proved to skew heavily on the works of Philodemus, to the point that as early as 1907, it was suspected that this library, known as the Villa of the Papyri, might actually be the collection of Philodemus himself. While some destructive unrolling of some of these scrolls has happened over the last few centuries, most remained untouched and unread. Until now. Modern methods of infrared photography and other techniques have allowed these formerly impossible to read texts to not only be reconstructed and read, but without damage to the original and the need to unroll them in their delicate state. This has revealed much more of Philodemus's works than would have otherwise been lost forever, and possibly even more than that. It's thought that there may be an unexcavated lower section of this library that may contain any number of scrolls that could in the future reveal even more lost works of the Greco-Roman world. Philodemus's works, however, confirm that the philosophers of the Greco-Roman world spent no small part of their time pondering existence in the universe, and debating such things as inductive reasoning and forming conclusions about the universe. Little did they know that 2,000 years later, we would still be doing the same thing, though armed with a much greater body of knowledge. But this task of understanding the universe around us creates a question. Will we someday understand it all? Will we ever have a complete understanding of the universe? In a literal sense, the answer is no. The universe puts certain limits on what we can know, but maybe not what we can understand. A glaring example of this is the interior of a black hole, which in most ways is not observable. Further, what we can know is also limited ultimately by the speed of light. We can't see some portion of the universe, for example, and never will be able to. The reason for this is the cumulative expansion of the universe past a certain distance, inside of which is our observable universe. Outside defeats the speed of light, making some large fraction of the universe forever invisible to us. Understanding the universe, however, is a different story than knowing everything, however. So to take stock of what we might even eventually be able to understand requires us to take a look at the limits. The first major limit that stands in our way of knowledge is the ability to measure something. The quantum world is hopeless in this regard. It simply doesn't work on a basis where you can repeat observations. All you can do is work with probabilities and averages. The reason for this is the infamous quantum wave function. Until you observe a particle, it exists in all states at once. Given this inherent uncertainty within quantum mechanics, it may be that we are never able to fully know the quantum world, but we may reach a full understanding of it. Or it could be that all interpretations we have are wrong, and some new interpretation of the quantum world will come along and make the picture clearer. But it doesn't just stop at the quantum level. There are things in the universe so complex that we may never truly be able to predict them. One of these, unsurprisingly, is the weather. Incorrect weather forecasts are ultimately wrong simply because the system being studied is too complex to be precisely calculated. There are many such examples of this, organic chemistry being a huge one where protein complexity just gets so overwhelming it's enormously difficult to tackle, though artificial intelligence is making inroads there. Another could well be cosmology. The universe might simply be too complicated to fully understand. There, scientists search and hope for simplicity. The physicists call it elegance, a single small equation that constitutes a theory of everything. But those hopes may well be dashed by a highly complex and even chaotic reality. The universe does not have to reduce itself down to a simple answer. And it doesn't just stop with the universe. There's always been the question of what lies outside the universe, or what existed before it. The answer given typically has been that the question is meaningless. The universe is, was, and will be everything, and there's nothing else. That was until the idea of the multiverse came into play. That this may be just one universe among many, like bubbles in a bathtub. The problem is, it's very likely we can't ever measure that. It's been suggested that cold spots in the cosmic microwave background radiation might represent dents of sorts where other universes bumped into this one. But that's never been proven. Otherwise, there simply isn't any known way to detect another universe, because any information on it simply is not available inside our own universe. It is all we can ever know, and anything outside it, or before it, may forever be an open question. That's assuming, however, that the universe is not cyclic. In cyclic conformal cosmology, Roger Penrose has suggested that if that model is correct, this is just one iteration of the universe that repeats over and over. It's possible that remnants of black holes from the previous universe to this one might also be spotted in the cosmic microwave background. So far, nothing definitive has been seen. But there are other issues with interpreting the universe that we may actually never get past. First is that we have all too human brains using all too human logic, which we use the imprecise tool of language to try to get across. That's layers of imprecision. An illustration of this is attributed to another Greek philosopher, Eubulides of Miletus. It goes like this: if you have a heap of sand with 1,000,000 grains, if you remove 1 grain, it's still a heap. Then you remove 100,000 more, and it's still a heap. But if you get down to a single grain, is it still a heap? A sort of silly paradox that sits on the shoulders of language imprecision, but it raises a point. How precise is language in describing the universe? Not great. Mathematics is much better, but less understandable to most humans. But is mathematics truly reliable? Well, we think so, but it's still resting on a base of axioms. Assumptions based on observation. You have to assume certain things are true to even start. So how do you explain all of this to an alien or an artificial sapient intelligence? You may not be able to. They may have some higher order of logic and truth and try to respond to you with something that may not make sense to a human brain. So does our very origin as human minds limit us in understanding the universe? Well, we can't tell. Take cosmology. We have some theories that work, quantum mechanics and relativity, but they don't fit together. We assume that our physics is merely incomplete and that there is a missing link. But it's also valid to suggest that our physical reality is not fully understandable to a human brain, in the same way as an octopus, as smart as they are, could figure out how to drive safely in a Chevy Malibu from Los Angeles to Chicago. In short, we may be the octopus, and we're not the smartest kids on the block. While unsettling, think for a moment about that idea. That as humans, we run the gamut of intelligence. We have smart people and not so smart people. We have specialized people that might be able to do mathematics in their head that most of us can't do, but at the same time can barely function socially. Some can be highly talented and skilled in one sector and have no abilities in another. In light of that, we might be able to reasonably ask that since we produce Einsteins, but most of us aren't Einsteins and tend to be specialized in our skills and pursuits, is it possible that there can be something, not Homo sapiens, that could automatically be good at everything, that takes intelligence to a level we as a species have never seen before? Could figuring out a complete picture of the universe require a skill that Homo sapiens does not inherently possess? Or even more poignantly, are we really the highest expression of intelligence that this planet will ever see? We might like that idea, but the answer is very likely no. This question is often framed in terms of superintelligence, either through augmentation to make the human brain smarter, or artificial intelligence, where we create a machine smarter than we are. But it may not be that complicated. It may simply be that we are another stepping stone to something evolving that is smarter than we are. This was the case for all of humanity's hominid precursors. They generally became increasingly intelligent as each successive species evolved, before promptly going extinct. Homo erectus might have thought it the most intelligent species on Earth, if it could conceive that, but wouldn't have realized in the future far more intelligent Homo sapiens would arise. Maybe we're in that boat, and the reason we don't understand the universe fully is because we don't have the brain power for it. But our evolutionary successors, should hominids continue to evolve, may be far better at understanding the universe than we are. That's actually a variation on a solution to the Fermi paradox. All civilizations go extinct after a very short time. That might make sense. If you are a precursor species to something capable of founding a galaxy-spanning Kardashev Type 3 supercivilization, and you cause your own extinction before you get there, then no Type 2 or 3 ever results. There is only a brief period of half superintelligence that always leads to extinction, and in the grand scheme of things, civilizations just blink in and out and never exist in enough numbers to detect each other. And lastly is the great unknown of infinity, which by definition means we can't ever know everything. Infinity is weird, because there are basically two types according to the math. You can count from 1 to 2, then 3 and upward to infinity, but you can also count another way, 1.1 to 1.2 to 1.3, all the way to infinity. That sounds suspiciously like a semantic language problem, but infinities show up all over cosmology, whether it's big bangs, the size of the universe, or black holes. Maybe they don't really exist, and are an artifact of mathematics and our attempts to describe the universe. Perhaps there's a point where the math no longer holds true. To know for sure, we'd very likely have to ask someone else. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently eyeing the universe suspiciously. I admit it, we don't fully understand it. But what happens if it doesn't fully understand us? That's about the worst misunderstanding possible. Not good. Or maybe it is, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular, in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.